Welcome to ACE Online. Myself, Madhushekar, faculty of ACE Engineering Academy from last 7 years. I'm here to discuss about this TSPSC Assistant Engineer revision series. Here, important questions with a detailed analysis of the subject Production Technology Part 1. The second part, my colleague Ravi Sir will take. So today, Part 1, I'm going to discuss some of the important questions. Before going to that, first I'll discuss the syllabus and weightage analysis of this production technology. As you are familiar, the production technology is one of the biggest subject in mechanical. The number of questions, also huge number of questions asked in 2015 AE exam. There are 26 questions they asked, a huge number of questions. In AEE 40 questions, right? HMW, SSB, 40 questions, 30 questions, like that. Approximately more than 20 questions they will ask you from the production technology, right? So you should focus on this subject, right? Now here, I'm going to deal today these topics here, the metal forming, different metal forming operations like rolling, forging, extrusion, and wire drawing, tube drawing, and different sheet metal operations also I'm going to discuss, that is punching, blanking, deep drawing and bending, and different machining operations like milling, grinding, shaping, planing, lathe cutting, all these things. Metrology, different important devices used in metrology and important things, allowances, pits, all these things I'm going to discuss. And metal cutting, important concepts related to tool life equations, all these things I'm going to discuss with the questions. I framed here some important questions, and from those questions I will explain these things one by one, right? So here, one by one, I'll explain. The first question, let us consider the state of stress during deep drawing. The state of stress during deep drawing forming operation of a cup is. Listen, in case of deep drawing operation, okay, in case of deep drawing operation, if I consider a cup, in case of deep drawing operation, if I consider a cup, this is a die, okay, this is a die, and this is, here I am considering a partially deep drawn cup. Here I am considering a partially deep drawn cup. So this is a partially deep drawn cup. But without applying any blank holding force, the cup, flange portion of cup is going to be lifted upwards. And if I consider this is a punch, if I consider this is a punch force, right? So they are asking a question, right? At a flange portion, what type of stress is present? At flange portion, what type of stress is present? Okay. So a flange portion లో ఏ స్ట్రెస్సెస్ ఉన్నాయి అది కనుక్కోవాలి మనం, ఓకేనా? ఫ్లేంజ్ పోర్షన్లో స్ట్రెస్సెస్ ఏవేవి ఉన్నాయి అది కనుక్కోవాలి. ఇక్కడ ఫోర్స్ అప్లై చేసినప్పుడు బ్లాంక్ హోల్డింగ్ ఫోర్స్ లేదనుకోండి, అంటే హోల్డ్ చేసే ఫోర్స్ లేదనుకోండి, ఒకసారి ఫోర్స్ అప్లై చేస్తే షీట్ మెటల్ లిఫ్ట్ అయిపోతుంది. లిఫ్ట్ అయ్యి వేవ్స్ జనరేట్ అవుతాయి, వ్రింకిల్స్ జనరేట్ అవుతాయి. అలా వ్రింకిల్స్ జనరేట్ అయినప్పుడు టెన్షన్, కంప్రెషన్ రెండు జనరేట్ అవుతాయి ఫ్లేంజ్ పోర్షన్లో. అదే ఈ రీజియన్లో అయితే ఓన్లీ టెన్షన్ ఉంటుంది, ఓకే? ఈ రీజియన్లో టెన్షన్ అండ్ కంప్రెషన్ ఉంటుంది, ఈ రీజియన్లో ఓన్లీ టెన్షన్ ఉంటుంది. సైడ్స్కి బాటంలో కూడా ఓన్లీ టెన్షన్ ఉంటుంది. ఆర్ బ్లాంక్ హోల్డింగ్ ఫోర్స్ ఉంటే టెన్షన్ ఉంటుంది, లేదంటే ఆ టెన్షన్ కూడా ఉండదు, రైట్? ఒక ఆప్షన్ చెక్ చేద్దాం ఇప్పుడు. ఇన్ ద ఫ్లేంజ్ ఆఫ్ బ్లాంక్ uniaxial compression and in a wall of cup biaxial tension and compression. No. Flange portion lo uniaxial compression undadu. Next. In flange of the blank uniaxial tension and in wall of the cup biaxial compression. No, uniaxial undadu. in flange portion of the blank biaxial tension and compression. Okay, flange portion lo tension and compression రెండు ఉంటాయి and wall of the cup లో simple uniaxial tension ఉంటుంది. So C is the correct answer. C is the correct answer. So remember, ఒకసారి షీట్ని డై మీద పెట్టేసి ఫోర్స్ అప్లై చేస్తే షీట్ ఫ్లేంజ్ పోర్షన్ షీట్ అనేది లిఫ్ట్ అయిపోయి వేవ్స్ జనరేట్ అయ్యి ఒక రీజియన్లో ఏమో టెన్షన్, ఇంకో రీజియన్లో ఏమో కంప్రెషన్, సో బయాక్సియల్ స్ట్రెస్సెస్ జనరేట్ అవుతుంది. అదే కప్ సైడ్ వాల్స్కి ఏమో ఓన్లీ టెన్షన్ ఉంటుంది. ఓకేనా? సో సి ఈజ్ ద కరెక్ట్ ఆన్సర్. నెక్స్ట్ క్వశ్చన్. In a sheet metal of 3 mm thickness, okay, the thickness of the sheet is given 3 mm and a hole of 7 mm diameter. So in the question 7 mm diameter D is given, needs to be punched. The yield strength in tension of the sheet material is 120 megapascal. So in the question yield strength is given and ultimate shear strength is also given, okay, 100 megapascal. The punch force required. So this type of questions definitely they will ask in exam because calculator is not required. Simple basic question. So punch force or maximum punch force is nothing but sheared area, that is pi dt into shear strength of the material. Here pi into diameter 7 mm, thickness 3 mm into 100. Now pi is 3.14 into 7 3s are 21 into 100. So 3 into 2, that is 6 approximately will get, right? So here this is 7.9 not correct, 11.6 not correct, 13.6 not correct. So this is the answer. 3 into 2, 6 kilonewtons, 6.6 kilonewtons. So B is the correct answer. This type of questions they will ask you for exam without calculator. Okay, now without calculator they will ask you this type of questions, right? Next. The initial blank diameter required to form a cylindrical cup of outside diameter D and a total height h having a corner radius r is obtained by using the formula. So here listen carefully. So they are going to make from a sheet of the initial blank diameter dB, from the sheet to a cup. They are going to make like this cup from the diameter, right? Here the cup diameter, let us say this is D and height of the cup is h. Actually this you will get by equating one side surface area of cup to the one side surface area of the blank. One side surface area of blank is pi by 4 dB square is equal to bottom area of the cup pi by 4 d square plus pi dh. Now dB square is equal to d square plus 4 dh. Now dB is equal to under root d square plus 4 dh. d square plus 4 dh. Here out of these 4 options, okay, the first option is correct. You may get doubt, sir, what is this? In case in the question paper if it is corner radius is given, then you should take minus RC by 2, like that you should consider. So no need to worry regarding that. So A is the correct answer. Simple question. This type of questions they will ask you for your exam. Okay, na? This type of questions they will ask you for your exam. Next question. With a punch for which the maximum crushing stress is 4 times the maximum shearing stress of the plate. Okay, maximum crushing stress, see here, maximum crushing stress is 4 times of maximum shear strength of the plate. The biggest hole that can be punched in the plate would be of the diameter equal to. Now sigma C, that is equal to F max, maximum punch force, by area on which the force is applied, pi by 4 d square. Here you can write F max is nothing but pi dt into tau u by pi by 4 d square. So d cancel out, pi cancel out. Sigma C is equal to 4 T tau u by d. Right, and I want what is the diameter of the punch that is equal to. So d is equal to 4t tau u by sigma c. Right, and sigma c is 4 times of tau u, 4t tau u by 4 tau, 4 tau. So this cancel out. So d is equal to the plate thickness. This question also asked in ISRO. Very, very important. So remember, this formula is very, very important for example. Okay, this is the punch diameter, maximum punch diameter or minimum punch diameter. This is the crushing stress. This is the crushing stress applied on the body. Right, everyone getting? Right, everyone getting? Right. Now, listen. This is the formula. Next, another question. In a single pass rolling operation, the thickness of 100 mm wide plate is reduced from, see here, listen, this is the width of the plate W, is reduced from 20 mm to 15 mm wide plate. This is 20 mm H0, this is 15 mm H1. Roller radius is 125 mm. Right, and rotational speed is 8 rpm, speed n is given 8 rpm. Then the average flow stress of the material is 400 is given, y bar f is given, average flow stress of the material. Then the power required in the milling, power required in rolling operation, power required in rolling operation, right, power required in rolling operation. So generally most of you people, by seeing this question, it's a numerical, without calculator how can we solve? But this type of questions also they'll ask. Those people who can able to solve this type of question, they are in the top list. Because other people, most of the people, they'll attempt theoretical type questions. But those people who are able to do this type of question, they will get good marks. Now see here, power is equal to 2 into T into torque into omega. Because 2 rollers into torque into omega. Now 2 into Fr rolling force into L by 2. Okay, rolling force into perpendicular distance L by 2 into 2 pi n by 60. Right, now Fr is equal to, now listen, P is equal to 2 into Fr is equal to y bar f into, okay, W into L, that is nothing but root of R into delta H into L, that is root of R into delta H by 2 into 2 pi n by 60. Right, L is equal to root of R into delta. This is the projected area, this is L by 2. Now from this you can simplify 2 into y bar f into W into R into delta H into, okay, delta H by 2, delta H by 2 into 2 pi n by 60. Now substitute the data, this two cancel out, okay, this two cancel out. Now y bar f is 400, W is equal to 100, R is equal to 125, delta H is 520 minus 15, 5 into pi into 8 rpm by 30, 8 by 30, 8 by 30. Here you no need to consider pi value you can take as it is, right. Now see here, this one cancelled out. Now this is 4000, this is 125 into 5, 125 into 5, 625, 625 into 8, 4000 into 125 into 5, 625 into 8, that is approximately you will get 20 pi by 3. By solving this in a simple way, 20 pi by 3 kilowatts you will get. Okay, simple question, 25 by 3. This is 625 into 8, approximately you will get 5. So 5 into 4, 20, 25 by 8 you will get. So this is the answer. Simple question. Next question. It is actually a match the following question. In the list 1, they asked process, and in the list 2, they asked property. Cold rolling, hardness, impact load, wide drawing. Now, remember, by doing cold rolling, ductility of the material decreases, strength of the material increases. Residual stresses are induced. Hardness is the ability of material that can resist the indentation or penetration. Impact loads, ability to absorb impact energy, resilience. Wide drawing, ductility. Now listen carefully, if you match these things, listen. Hardness is related to indentation, Q is equal to 1. To do the wide drawing, ductility is required. Impact loads, resilience. So cold rolling is malleability. So P is 3, Q is 1, R is 4, S is 2. So B is the correct answer for this question. B is the correct answer for this question. Right. B is the correct answer for this question. Now the next question. Ring rolling is used. Options given: to decrease the thickness and increase the diameter, to increase the thickness of ring, for producing a seamless tube, for producing a large cylinder. Listen, the ring rolling is an operation of increasing the diameter of a tube, diameter of a ring actually, diameter of a ring, and reducing the thickness of ring. Now see this image, here this is a ring, okay, solid with a huge thickness ring. Now by using these rollers, I am applying rolling operation so that I can reduce the thickness of the ring and I can increase the diameter of the ring. So out of these 4 options, I can reduce the thickness of the ring by using ring rolling and increase the diameter. Very, very important. And one more, skew rolling. Skew rolling, generally, listen, skew rolling is used to make spherical balls. Remember, skew rolling is used to make spherical steel ball or spherical balls. So don't confuse, skew rolling is used to make spherical balls. Ring rolling is used to decrease the thickness and increase the diameter of the ring. Okay. Next question. The maximum possible draft in cold rolling of sheet increases with. The maximum possible draft in cold rolling of sheet increases with. Now listen carefully. Maximum possible draft in the rolling operation, it is possible. The condition for maximum possible draft is tan beta is equal to tan alpha. Friction angle is equal to bite angle, that is under root delta H by R. So delta H max per pass is equal to mu square R. Remember, delta H max per pass is equal to mu square R. Now this maximum possible draft depends on the friction and roller radius. So delta H max proportional to mu u, delta H max proportional to R. Right. So maximum possible draft of sheet increases with increasing the coefficient of friction. Decreasing the coefficient of friction is not correct. Decreasing the roller radius is not correct. Increasing the roller velocity is not correct. So this is the correct answer. Very, 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 very important. This equation is also very, very important for exam. Right. Okay now? Next. A solid cylinder of diameter 100 mm and height 50 mm is forced between 2 frictionless flat dies to a height of 25 mm. So remember, initial diameter is 100 mm, initial height is 50 mm, H0, and is forced between 2 frictionless flat dies to a height of 25 mm. So final height is 25 mm. The percentage change in diameter they are asking. Generally in the forcing operation, we know that the volumetric change is 0. So A naught H naught is equal to A1 H1. So pi by 4 D naught square H naught is equal to pi by 4 D1 square H1. Pi by 4 D naught square H naught is equal to pi by 4 D1 square H1. Now we don't know the D1, so D1 is equal to D naught under root H naught by H1. Right, so D naught is 100, okay, into under root H naught is 50 by 25. So 100 into root 2, that is actually 141.4. Right, D1 is 141.4. Percentage change in diameter they are asking. Percentage change in diameter, that is percentage change in diameter, that is D final minus D initial by D initial into 100. Right, so D final 141.4 minus 100 by 100, right, into 100. So you will get 41.4 percentage you will get. So D is the correct answer for this question. Right. So D is the correct answer for this question. So 41.4 percentage without using any calculator. Root 2 is 1.414. So right. So by multiplying with 100, 141.4 you will get. That's why from that I am getting this one. Right. Next question. Cold working produces the following effect. Now the stresses are set up in the material. Yes, by doing cold working operation, the internal residual stresses are set up. And grain structure get distorted. Yes, definitely the grain structure distorted. And strength and hardness of metals are decreased. Strength and hardness of metals are decreased. It is not correct. Surface finish is reduced is not correct. Remember, in case of cold working, okay, the strength and hardness of material is increased because of strain hardening. Surface roughness is low, coefficient of friction is low. Only the problem is low ductility and high forces are required. But in case of hot working, ductility increases, toughness increases, but strength and hardness decreases. But due to scales formed on the surface of hot billet, the friction is more, surface roughness is more. So third and fourth statements are correct, right? Wrong. So 1 and 2 are correct. So A is the correct answer for this question. A is the correct answer for this question. Next, right? Next, the cutting force in punching and blanking operations mainly depends on. You see here, the cutting force, let us say F max, okay, that is sheared area into ultimate shear strength, because in case of punching and blanking, the sheet metal is going to be sheared. That's why it only depends on the sheared area and ultimate shear strength of the material. So it is independent of modulus of elasticity, it is independent of bulk modulus, it is independent of yield strength of material. It only depends on shear strength of the material. Right. It only depends on shear strength of the material. The cutting force in punching and blanking operation mainly depends on shear strength of the material. Next question. In blanking operation, the clearance is provided on. In blanking operation, the blank size is equal to the die size. So clearance is provided on punch. Remember, this is very, very important. I will give you this table. This is very, very important for exam. Punching and blanking, punching and blanking, if I consider, punching and blanking, if I consider, right, this is clearance, okay, and this is shear, you remember. To reduce the maximum punch force, we are also providing shear. In case of punching, hole size is equal to punch size, so clearance is provided on die. In case of blanking, the blank size is equal to the die size, so clearance is provided on punch, but it is reverse in case of shear. In case of punching, you should provide shear on punch only, otherwise hole or sheet is going to be damaged. So shear is provided on punch. In case of blanking, you should provide shear on die only, otherwise the blank is going to be damaged. So this table is very, very, very important for exam. Okay, na? This table is very, very important for exam. This table is very, very important for exam. Okay, now next point. This is another question from bending, frequently they'll ask. Now see here, a 2 mm thick metal sheet, a 2 mm thick metal sheet is to be bent at an angle of 1 radian, is to be bent at an angle of 1 radians, okay, 1 radian, with a bend radius of 100 mm. If the stretch factor is 0.5, the bend allowance, listen carefully, bend allowance, right? Bend allowance ante entante ikkada, okay, r plus kt into alpha, right? r is the radius of the bend. So radius of the bend ఎంత ఇచ్చాడండి ఇక్కడ 100, stretch factor ఎంత అండి 0.5, thickness of the bend ఎంత అండి 2 into 1 radian. So you will get 101 mm. 101 mm is the answer. So this is the correct one. So remember, bend allowance formula, ఈ formula చాలా ఇంపార్టెంట్ అండి మీకు. ఓకే, న్యూమెరికల్స్ అడుగుతాడు వితౌట్ క్యాలిక్యులేటర్ 1 minute లో చేసే క్వశ్చన్ అండి ఇది. సో బీ కేర్ఫుల్. క్వశ్చన్, బెంట్ రేడియస్ ఇస్తాడు, స్ట్రెచ్ ఫ్యాక్టర్ మ్యాక్సిమం ఇస్తాడు, లేదంటే 1/2 తీసుకోండి, థిక్నెస్ టీ, ఆల్ఫా వచ్చేసి రేడియన్స్లో ఇస్తే నో నీడ్ టు కన్వర్ట్ ఇన్ టు డిగ్రీస్, డైరెక్ట్లీ యూ షుడ్ యూస్. ఇన్ కేస్ డిగ్రీలో ఇస్తే మల్టిప్లై విత్ π/180. డోంట్ ఫర్గెట్, మర్చిపోదండి. డిగ్రీస్లో ఇస్తే π/180 తీసుకోవాలి, రేడియన్స్లో ఇస్తే నో నీడ్, డైరెక్ట్లీ యూ కెన్ సబ్స్టిట్యూట్. ఓకేనా, అర్థమైందా అండి? రేడియన్స్లో ఇస్తే సబ్స్టిట్యూట్ చేసుకోవాల్సిన అవసరం లేదు, డిగ్రీస్లో ఇస్తే యూ షుడ్ సబ్స్టిట్యూట్, మీరు సబ్స్టిట్యూట్ చేసుకోవాలా, రైట్? ఓకే, నౌ is there any doubts? Okay, next question. In sheet metal working, the spring back increases. Spring back, this is also important. ఇక్కడ ఒక ఫార్ములా ఇస్తాను, బట్ ఆ ఫార్ములా గుర్తుపెట్టుకోవాల్సిన అవసరం లేదు. ఐ విల్ టెల్ యూ. స్ప్రింగ్ బ్యాక్ ఫ్యాక్టర్ అని ఉంటుంది. ఈ స్ప్రింగ్ బ్యాక్ ఫ్యాక్టర్ K is equal to final bend angle by initial bend angle or initial radius of the bend to the final radius of the bend. Is spring back factor, that is equal to formula Ri into sigma y by E into T whole cube minus 3 into Ri into sigma y by E into T plus 1. ఇది ఫార్ములా. ఈ ఫార్ములా నుంచి ఇంపార్టెంట్ థింగ్స్ గుర్తుపెట్టుకోండి. Spring back factor is proportional to, okay, Ri by T. థిక్నెస్ తగ్గితే స్ప్రింగ్ బ్యాక్ ఎఫెక్ట్ ఎక్కువ ఉంటుంది, థిక్నెస్ పెరిగితే స్ప్రింగ్ బ్యాక్ ఎఫెక్ట్ తక్కువ ఉంటుంది. స్ప్రింగ్ బ్యాక్ ఫ్యాక్టర్ ఈజ్ ప్రపోర్షనల్ టు 1 యంగ్స్ మాడ్యులస్. యంగ్స్ మాడ్యులస్ ఎక్కువ ఉందంటే స్ప్రింగ్ బ్యాక్ ఎఫెక్ట్ తక్కువ ఉంటుంది. నౌ స్ప్రింగ్ బ్యాక్ ఫ్యాక్టర్ ఈజ్ ప్రపోర్షనల్ టు ఈల్డ్ స్ట్రెంగ్త్ ఆఫ్ ద మెటీరియల్. ఈల్డ్ స్ట్రెంగ్త్ ఎక్కువ ఉంటే స్ప్రింగ్ బ్యాక్ ఎఫెక్ట్ ఎక్కువ ఉంటుంది. నా ఇక్కడ క్వశ్చన్లో ఆప్షన్, ఇక్కడ స్టేట్మెంట్ చూద్దాం. ద రేషియో ఆఫ్ బెండ్ రేడియస్ టు షీట్ థిక్నెస్ ఈజ్ స్మాల్. సి, స్ప్రింగ్ బ్యాక్ ఫ్యాక్టర్ ఇంక్రీజ్ అవ్వాలి అంటే రేషియో ఆఫ్ ఇనిషియల్ రేడియస్ టు ద బెండ్ రేడియస్ టు ద థిక్నెస్ షుడ్ బి హై, లార్జ్ ఉండాలి. ఇక్కడ ఇది స్మాల్ అన్నాడు, తప్పు కదండి. నెక్స్ట్, యంగ్స్ మాడ్యులస్ ఆఫ్ ద షీట్ మస్ట్ బి లో. సో ఇది ఇంక్రీజ్ అయితే ఇది లో ఉండాలి, ఇది రైట్. నెక్స్ట్, yield strength of the sheet is high. This is also right. Tension applied during the bending. Tension applied during the bending అంటే బెండింగ్ చేసేటప్పుడు టెన్షన్ అప్లై చేస్తే స్ప్రింగ్ బ్యాక్ ఎఫెక్ట్ తగ్గుద్ది, స్ట్రెచ్చింగ్ అంటాం దాన్ని. సో ఇది కూడా కరెక్ట్ కాదు. సో Q and R కరెక్ట్ ఆన్సర్స్. సో ఇలాంటిది ఈ ఫార్ములా గుర్తుపెట్టుకోకుండా జస్ట్ ఈ పాయింట్స్ గుర్తుపెట్టుకోండి, ఇంపార్టెంట్ ఫర్ ఎగ్జామ్. స్ప్రింగ్ బ్యాక్ ఫ్యాక్టర్, ఓకేనా, it is directly proportional to Ratio of radius of bend to the thickness, inversely proportional to the Young's modulus, directly proportional to the yield strength. Next point. Next one. The crank pin is to be connected in a bush and the dimensions for the bush and crank are given respectively in mm. These are the dimensions for bush. These are the dimensions for crank. Okay, and maximum clearance between bush and crank pin. Right. So maximum clearance, how will you get maximum clearance? How will you get maximum dimension of bush, maximum dimension of bush minus minimum dimension of crank. So maximum dimension of bush is 16 plus 0.17, 16.017 minus minimum dimension of the crank, that is 16 minus 0.0. Listen here. Otherwise, in a simple way, I'll write here, listen carefully. I'll write in a simple way here, listen carefully. 16 plus 0.017 minus, okay, 16 minus 0.062. Now this 16 cancel out. 0.017 plus 0.062, that is 0.079 mm you will get. This is the maximum clearance, right? So if you see the options here, this is the correct one. So no need of calculator, 1 minute question only. This type of questions they will ask you for exam. Okay, na? Be careful, right? Next one. A master gauge is mainly used for which of the following purpose? Master gauge here. Checking thread cutting angle? No. Measuring the internal diameters? Verifying the accuracy of gauges used on shop floor. Now, on shop floor there are so many gauges. Some of these gauges sometimes they are not working properly. So, to measure the accuracy of those gauges which are in the shop floor, to measure that accuracy level, we are using master gauge. The name itself, it is there, master gauge, remember. So C is the correct answer for this question. Okay, we are using master gauge. We are using master gauge to verify the accuracy of gauges used on shop floor. Next. Gear tooth vernier is used. The gear tooth vernier is used to measure the addendum. No, not correct. It is used to measure the addendum and dedendum. Not correct. It is used to measure the circular pitch. It is used to measure the pitch line thickness of the tooth. It is used to measure pitch line thickness of tube. The pitch line, let us say this is the pitch line thickness of tooth, the pitch line thickness of the tooth. So this is we are using. So gear teeth is used to measure the pitch line thickness of tooth. Right. Next. The milling machine is classified as horizontal or vertical type depending on the position of, listen, there is a vertical spindle milling machine, horizontal spindle milling machine, like that two types are there. So that depends on the spindle, right? So if you see the options here, spindle, workpiece, milling cutter and work table, so spindle is the correct answer for this question. So vertical spindle milling machine, horizontal spindle milling machine. So based on the spindle position, we are dividing that into horizontal or vertical. So A is the correct answer. Next. The size of shaper is specified by, remember the size of shaper is specified by the length of the stroke or length of the cut, how much cut it is, how much length of the stroke it is. So it is independent of the size of the table, maximum size of the tool, or ratio of forward to return stroke. So A is the correct answer. Length of the stroke. A is the correct answer. Size of the shaper is specified by the length of the stroke. Next. Now, in a taper turning operation, the maximum and minimum diameters of job are D, capital D and small d respectively. What is the taper angle if the job length is L? Now, listen carefully. Listen carefully. This is the taper turning operation I am considering. Here, this diameter is capital D and this diameter is small d. Right. The tapered angle or a taper angle, how can we get? Theta is equal to tan inverse, okay, d minus d by 2 by L. So from this you will get tan inverse, okay, capital D minus small d by 2L. Right. So this is the information. Now here out of these four options, A is the correct answer for this question. A is the correct answer for this question. Next, the grit size of abrasives used in the grinding wheel usually specified by. It won't represent the hardness number, it won't represent the size of the wheel, it won't represent the softness of hardness of the abrasive, but it will represent the mesh number. The grit size depends on the, the grit size represent the mesh number. Okay, na? So D is the correct answer. Now, the grinding wheel is considered better if the grinding ratio, what is actually the grinding ratio? The grinding ratio means, okay, the volume of material removed from the workpiece by volume of material removed from the grinding machine, okay, the volume of material, raw material removed, volume of grinding material. So if the grinding material, if it is more removed, abrasive is more damaged, then it is going to be reduce the efficiency. So grinding ratio, the grinding ratio should be high. More, see here, volume of raw material removed must be very high compared to volume of wheel wear. So it should be maximum. Remember, grinding ratio should be maximum to get a better grinding wheel, so that more raw material is removed, less wheel wear. So A is the correct answer for this question. A is the correct answer for this question. Right. Now, listen, next one. In which milling operation is the surface finish is better? In which milling operation the surface finish is better? Now let us consider, here there is one up milling, there is one down milling. In case of up milling, the tool and the wheel is rotating in the opposite direction. This is up milling, this is down milling. Now let us consider, in case of down milling, the initial cutting will start here. And this is going to be decrease, here decreases. So smooth surface finish is formed here. But in case of this one, initially more cutting will start here. So that is going to be obstructed, nor uniform surface is going to be formed. So down milling is the correct answer. So smooth surface finish will get in case of down milling. Next, the operation of finishing a drill hole to its right size is known as. Finishing a drill hole to exact right size, exact size. So after drilling, you will not get exact size. To get exact size, we should go for reaming. Reaming is minute layer from the drill is removed. So A is the correct answer for this question. A is the correct answer for this question. Reaming. Next, which one of the following primary purpose to do the flutes on twist drill? flutes and twist drill, right? Generally, flutes and twist drill is used to remove the twist drill here on the workpiece. Let us consider it's a drill. So twists are there, right? These drills are used to remove the raw material easily, right? They curl the chips for easy removal of the chips, right? That is the best answer for this question, okay? The twists are provided for removal of the chips easily and providing rake angle, so that we are providing flutes. A is the answer. Next, which of the following is a non-chip removal process? Now listen, if you see this diagram, it's a lathe machine, right? Generally, most of us, what we will think, lathe machine is used to cut the material, chip removal, right? But in this lathe machine operation, we are making cups or bowls by using sheet. We are bending sheet metal forming. We are bending sheet metal forming by using, okay, lathe machine, that is known as spinning. By spinning of the material, we are making a cup. So that is spinning on lathe, spinning on lathe. So non-chip removal process is spinning on lathe. Non-chip removal process is spinning on lathe. So A is the correct answer for this question, right? A is the correct answer for this question. Next one. Select the correct sequence of the following parameters in descending order of the influence of tool life. Remember, the cutting speed will influence more, first of all, then feed rate, then depth of cut. So 3, 1, 2 is the correct answer for this question. So more influencing is cutting speed, then after that feed rate, then after that depth of cut. So B is the correct answer for this question. Okay, now B is the correct answer for this question. Next question. Orthogonal cutting system is also called as. Orthogonal cutting system is a two-dimensional cutting system. Okay, it is a two-dimensional cutting system. We are calculating the cutting forces by considering a plane. That's why it's an orthogonal cutting system. We are calculating the cutting forces by considering the plane. That's why it's a two-dimensional cutting system. So B is the correct answer. Okay, na? Orthogonal cutting system. Next. A steel bar of 200 mm diameter is turned at a speed of 0.25 mm revolution. The depth of cut 4 mm. Right. The rotational speed of the workpiece is 160. Then material removal rate. Remember, material removal rate they are asking. The material removal rate, if they are asking, listen carefully, if they are asking material removal rate, the formula is feed into depth of cut into velocity. Right. Now, feed is how much given? Enti chadandi 0.25. Depth of cut enti chadandi 4. But velocity valedu. Revolution per minute and diameter ichinaadu. So pi, okay, d 200 n 160 by pi dn by 60. See here I am writing formula. Feed into depth of cut into pi dn by 60. Right. So simplify this. This is equal to 1. And solve this one. Let us say here simply I will solve this one. This is cancelled out. This is 4 or 8. This is 3. Right. So this is approximately 3.14. This one cancel out na. Next enti 200 into 8 1600 అవుతుందా 1600 ఆన్సర్ ఉంది ఇక్కడ 1600 ఆన్సర్ ఉంది కానీ ఇక్కడ 3.14 కదా 3.14 into 0.14 ఆల్సో యాడ్ చేయాలి 1.14 యాడ్ చేస్తే 1675 అంతే సింపుల్ క్వశ్చన్ 1600 ఉంది బట్ ఇక్కడ 3.14 కదండి సో 0.14 కూడా యాడ్ చేయాలి కదా 1.14 into 1600 వేస్తే అప్రాక్సిమేట్గా 1675 సో D is the correct answer. Simple. calculator is not required. This type of questions అడుగుతారండి. ఓకేనా? రైట్. నెక్స్ట్ క్వశ్చన్. A milling cutter having 8 teeth, number of teeth 8, is rotating at 150 rpm. Okay, if the feed rate for tooth is 0.1 mm, then the table speed in mm per minute table speed. Table feed for teeth is 0.1, number of teeth 8, revolution per minute 150. Right, so 8 into 150, that is approximately 120 you will get. 8 into 150, B is the answer you will get. Simple question, simple math units, you just match the units, you'll get the answer. Okay na, math cheste vastundi. Next, a super finishing operation which removes little amount of material and produce excellent surface finish on the internal surface, that is known as honing. Honing is a final operation or super finishing operation, especially internal hole. To create exact hole, super finishing operation is done by honing operation. Next, among the following machining processes, which can be used for machining of flat surfaces? ఫ్లాట్ సర్ఫేసెస్ ప్రొడ్యూస్ చేయడానికి షేపింగ్ వాడచ్చు, మిల్లింగ్ వాడచ్చు, బట్ బ్రోచింగ్ వాడమండి. బ్రోచింగ్ హోల్స్ తయారు చేయడానికి వాడతాం. హోల్స్ ఆన్ ఎ ప్లేట్, హోల్స్ ఆన్ ఎ బాడీ, రైట్? సో బ్రోచింగ్ కాదు, షేపింగ్ అండ్ మిల్లింగ్. సో ఏ ఈజ్ ద కరెక్ట్ ఆన్సర్. 1 and 2 ఓన్లీ కరెక్ట్. ఓకే, 1 and 2 కరెక్ట్ ఇక్కడ, రైట్? నెక్స్ట్ ఇంకోటి ఏంటి? నెక్స్ట్ క్వశ్చన్, వాట్ ఈస్ ద ప్రాసెస్ ఆఫ్ removing metal by a milling which is rotated against the direction of travel of the workpiece? Citizen, rotated against the direction of travel. Now see the diagrams here. This is rotating like this and this is also rotating like this, same direction, right? Now this is rotating like this and this is rotating like this, opposite direction. So this is up milling, opposite direction, this is down milling. Okay, up milling and down milling. So B is the correct answer. Rotated against the direction of travel, so opposite direction. So B is the correct answer for this question. Next one, which of the following is not a synthetic abrasive material? Silicon carbide, aluminum oxide, titanium nitride, cubic boron nitride. Silicon carbide is the correct answer. Silicon carbide is also an abrasive material, but it's not synthetic, it's natural. It's a natural one, that's why silicon carbide is not. Remaining these three are synthetic abrasives. Aluminum oxide, titanium nitride, cubic boron nitride. These are synthetic, but silicon carbide is not synthetic, it is natural. Next, another question. It is required to cut a screw thread of 2 mm pitch. Screw thread of 2 mm pitch on a lathe. The lathe screw has a pitch of 6 mm. The lathe screw has a pitch of 6 mm. Spindle speed is 60, right? Then the speed of lathe screw. Now, a simple question here, right? Let us consider the speed. Tell me spindle speed and lathe screw speed. Which speed is more? Spindle speed. Spindle speed is rotating very fast compared to the lathe screw. So lathe screw speed must be less than 60. If we check the options, 120 eliminated, 180 eliminated. Now only these two options. Now we'll solve the numerical. Now see here, 60 into, okay, that is the spindle speed into 2 by that is the thread pitch divided by lathe screw pitch, that is 6, that you will get 3, you will get 20 is the RPM, 20 RPM is the correct answer. It's a very simple question. Lathe screw velocity is less than the spindle velocity, spindle speed, right? Spindle speed, right? So this is the question answer for this is B. Now, gear lapping. Gear lapping is what actually? The gear lapping is a super finishing operation after making gear, after doing heat treatment. Okay, after doing heat treatment, we are finishing, we are removing minute layer on the surface. We are removing minute layer on the surface, that is known as gear lapping. An operation after heat treatment, an operation after heat treatment is known as gear lapping. So A is the correct answer. An operation after heat treatment is known as gear lapping. Next. Which of the given below surface lay produced by knurling operation? See, if you go for knurling operation, okay, if you go for knurling operation, the sheet is going to cut like this. This is a knurling operation. You will get cross lay. You will get the cross lay. Even I'll show you these things. Listen. Parallel lay, surface is produced by shaping and planing. By doing shaping and planing, you'll get parallel lay. Second, perpendicular lay, surface is produced by shaping and planing. Yes. Cross lay, the surface is produced by knurling operation. Multi-directional lay, surface is produced by grinding operation. Circular lay, the surface is produced by facing. And this is radial lay, by using lathe machine also you'll get, right? So, knurling operation, cross lay. C is the correct answer for this question. Next. The method of producing large diameter holes without drilling, complete material is not converted into chips. Here, to make, let us say this is my workpiece, right? I want to cut this material, I want to remove this excess material, complete excess material. So I am not cutting this material, I am not drilling this material like this. What I am doing, at lathe machine, okay, drilling machine, I am using two small size cutters, okay, like this, I am cutting like this. Here I am going to cut, here I am going to cut, so I can easily remove this block. That is known as trepanning. Now see here, this is a drill bit. By using these cutters, I am removing this complete portion, trepanning. Counter boring, enlargement of the hole. Here, counter sinking, like making conical shape of the holes like that. Counter sinking. Here also we are enlarging the holes by the tool is a conical shape. Here it is normal shape. So trepanning. Remember, enlarging large diameter of holes is produced without drilling complete material, that is known as trepanning. B is the correct answer for this question. Right. Next one. Which one of the following process sequences will give the best accuracy as well as surface finish? So order they are asking. So drilling first, then after that finishing operation reaming, then after that finally lapping, right? So drilling, reaming and lapping, super finishing operation lapping, reaming also super finishing. C is the correct answer. So drilling for making cylindrical holes, boring for enlarging the drilling holes, reaming for finishing of the holes, slightly remove the material, and lapping super finishing of the body. Next, the purpose of helical grooves and a twisted drill. The purpose of helical grooves in a twisted drills, these helical grooves. For what purpose? Remember, for what purpose we are providing space for chip removal. For removal of chip, we are using this one. Provide rake angle for the cutting edge. No need to save. This is not correct. Improve the stiffness. Stiffness is going to be reduced. So these two are not correct. So 3 and 4 are correct. So C is the correct answer for this question. Okay, na? Helical grooves are provided for space for removal of the chip and provide rake angle for the cutting edge. So C is the correct answer. Right. So these are the questions. Most of the questions I explained from these topics like machining, metal cutting and like metrology and metal forming and sheet metal operation. Right. And the remaining topics our colleague will discuss. And you should focus on most of the questions, you should focus on theoretical type, especially machining theoretical type questions, they will ask you grinding, milling, shaping, lathe machines, right? You should focus on these things. And thanks for listening. All the best for your exam.